Hi everyone, it's Nono here, and this is a live stream on creative coding and machine learning. We're gonna get started, and today's topic is gonna cover how to vectorize sketches with machine learning. This is something that we've seen before, and today we're just gonna quickly recap. And the focus of today is gonna be on how to render, how to draw those vector outputs that we're getting when we input a drawing into the model, and where we're gonna get actually our coordinates. We're gonna try to make sense of those and render them. For those of you who are new, who never have connected before, I'll invite you to like the video and support the work that I'm doing here, and to subscribe if you want to get notified when I go live next or when I upload new videos. I'm Nono Martinez Alonso. You can join our community at Nono de Masas Discord or go to the QR code up there. And you can also see last week's live stream was a bit long. We had a bit of a problem with the algorithm not working, but we managed to fix it, so you can use the chapters to skip ahead to the interesting parts. That's at nonodogma/live/62. And as always, you can submit questions about the latest episode of the Getting Simple podcast or any previous episodes at gettingsimple.com/ask. And you can use that for any type of questions, even for the live stream as well. And yeah, so we have the community goals. Before we move on, I would like to say hi to whoever is connected online. I'd love for you to tell us that you're connected, and say hi in the chat. If you're watching offline, you can say hi on the comments or on the Discord community. And yeah, so to get started, this live stream is gonna go sort of inside of the live stream goal of building a collaborative AI sketching platform. We're surveying different machine learning algorithms that we can use to manipulate our drawings, in this case, vectorize them. So if we have a raster scan or a sketch that we've drawn by hand or in some other method, we can basically line drawings can be vectorized, and this is stroke-based vectorization. And yeah, so that's what we're gonna do today. There's not a lot more that I can talk about there, and I'm gonna, as always, I'm gonna record a quick intro on the series in case that we this is stroke-based vectorization. And yeah, so that's what we're gonna do today. There's 1 second. So we're getting a notice here from Rob saying that there are multiple audio going. And okay, that was my bad. I don't know how long that happened. If that's happening from the very beginning, that sucks. All right, so let me recap a bit. So we have, probably there was an overlapping sound because YouTube was playing the live stream as well. So you could probably hear me 2 times. So we're gonna get multiple audio. No, it seems like a dupe delayed by 5-6 seconds. All right, so I'm gonna halt here, and you can tell me if it's sounding good right now. Thanks a lot for letting me know, because this is, otherwise I would have done the entire live stream that way, which would have been unbearable to watch. I'll wait here for a second and you can tell me. So it should be good now. All right, so we're waiting here. I'm just waiting to get a confirmation from Rob. Sounds good right now. Okay, let's get going then. So I'm gonna go back to presentation mode, and I was about to record an intro to the intelligence and sketching playlist, so we'll do that and we'll get started pretty soon. Hi everyone, it's Nono here, and this video is part of the Intelligence and Sketching playlist. Today we're going to take a look at virtual sketching. This is a machine learning framework, and I'm going to make a quick introduction to this framework as well. Hi everyone, it's Nono here, and this is a quick overview on how we can use the AI sketch vectorization output to animate or to render drawings that we've passed from vector form into vector output. So from raster form into vector output or format with a machine learning algorithm. So what we're going to use is something called virtual sketching framework, and the focus of today is to try to interpret the vector output, try to make sense of it, try to understand where the coordinates are and what the format is that we're getting. As we've seen in previous videos, that we can get with a Python notebook, we can get the vector form, stroke-based output from raster sketch input. All right, so without further ado, I'm gonna, okay, so if we're here, I have a, so this is an example of the output that you can get from virtual sketching. This is the sketch vectorization tool that I'm talking about. And as you can see, even if you get like a line drawing, you will get coordinates of different polylines or strokes that you can actually animate or trace in different ways later. These are output examples. So what you can see on the right is the vectorized output of different line drawings or drawings. You can see on the right that it's a bit weird when you get things that are not line drawings. And the color represents the time or like the moment in which they were drawn, because this network can actually draw the same thing starting at different points, and it will basically have a slightly different output, different color or order, right? So this represents the order in which these strokes were drawn. And this is just a comparison between input and sketch, where the sketch is actually the output of the network, and this is specifically what we did in live stream 62. We can see what we input on the top left is a hand sketch, and on the right we get the output. And I have this a bit more zoomed in here. We have the raster input on the left and the vector output on the right. And you know, you can, if we zoom into here, you can see that there are some artifacts, some like lines that are not continuous, that are faded on the drawing, get to disappear on the vectorized output. But for me, I think this is a really good result. I was impressed to see those results. And today we're going to try to interpret them and render them with code. All right, so the output that we got last week in live 62 we have here. So we were trying to input different images, and the one I was showing is this one. We were getting this output, and for some others, like the mutant image that is provided, we were getting this output. And I don't know if this might be the actual input. This is the output image, and for this one we were actually not getting good results because this is not a line drawing. And we tried with this image, but it didn't work properly. So there is a Google Colab Notebook, and instead of going through it right now, I'm just going to explain the high level concepts of what it does. We actually have to run this code to make sure that we install Python 3.6, because when this algorithm was first deployed in Google Colab, at least by me, I think that was live 39, we actually had Python 3.6 by default on the Colab Notebook. But now the default is 3.7, and you need to run this code to install 3.6 on the notebook and make sure that that's the default that both pip and Python are using on your notebook. And you know, you will oh, this is actually wrong, so let me just quickly fix that. Okay, so we would clone the virtual sketching repositories with this command, and then there's a series of steps that happen. We have to create the directories, mount the Google Drive, to copy and unzip the pre-trained model from there. That's just something that I did to make it easier. And then we vectorize, right? We run this command that says a Python test vectorization, and the input is image, right? Whatever image we want to use, we can use muden.png or some name of image that we upload there. With that, everything that we've talked about, if image.png is your input, you should get an output. We've seen moments where if the image is really large or has many strokes, it wouldn't actually render and generate the output, but I've seen that it generates the NPZ file, so the NumPy array of files file that actually contains the vector data. So that's what we're gonna inspect today. So without further ado, let's code and see how we can render our vector output. And if you're connected live and you have any questions, or if you're offline and want to write comments, let me know if you have any questions about this. We'll keep developing these slides and hopefully make them a bit more understandable. Okay, so we close that. And what I was mentioning that we can do today, I have these files here. Some of them are just PNGs, but if I sort these by type, you can see these NPZ files that show up on the folder. These are actually output by the model, and they're pretty small. Some of them are a bit bigger depending on the size of the image. I think this one, for instance, I think the larger ones, these two that are 129 KB and the one that is 70 KB, didn't work for the visual PNG output, and that might be because they're really large and they don't work properly. So the one thing you can do, and this might be really hard if you're watching this offline, so maybe I can copy this on the chat. There is on the live channel on the Discord server, there is this link that I'm going to copy. So just copy the link to the Sketch Vectorization notebook. I've created a new version compared to the one that we used last week, and this is what you can see. So I'm gonna put this, so Sketch Vectorization Colab Notebook. And I think I set up the right share access. So anyone with the link should be able to access this notebook already. All right, so we can close Discord and we have this notebook here. And you know, the one thing I wanted to do, we're gonna get GPU hardware accelerator on our notebook. And I just wanna make sure that the notebook as it is right now, we can run from start to bottom and anyone can get to use it. So this, I don't think we need it. So I'm gonna delete, I have this in another notebook. And let's actually clear all outputs because there's not that much code here. We don't need to download this from Dropbox anymore. So we are downloading from the Google Drive at the moment. And here I am looking at the thumbs 1024 image. This is not here by default. So maybe we can set input name. And thanks, Rob, for letting me know that you could access the notebook. We can set here, for example, muten.png, and we're going to use this input name. So let's simply try here that we can use this. So I'm just going to construct the NPC name as well. So that will be, we need this name here, and this will be NPC name. We can put it as lowercase because it's not a hyperparameter. And that for some reason doesn't work because it doesn't exist, right? So NPC name, and we replace that with not this, but just this, right? So we're gonna append that, and what we'll do is Let's just try printing input. Yes, and that should match the structure that we have in here. So we can set the input name, set input image, and vectorize. And we can actually set this in here. All right, so we haven't really touched a lot on this notebook, and the first thing I'm going to do is that I'm going to run the entire notebook, as I said. So I'm gonna factory reset the runtime, and we're gonna run all cells. And for those of you following the live stream, I can see that Rob is posting the model preparation download in the chat. So let's see if that happens, and that way you can. There's one thing that you need to do, right? And maybe we can do that to parameterize the notebook. There is a location that you need to have the pre-trained clean line drawings model, right? So this is the pre-trained model. So this is the pre-trained model path. And we're going to put that as a hyperparameter at the top, probably. We can do here settings, and we can put our variable here. That would be, let's see, so pre-trained model path. Because you can, you could copy or download or upload or put it anywhere, and we could actually put here input name. Input name, I'm not sure if I should put here, because you might want to just change it below and not have to rerun everything. This is something that is a bit confusing from, yeah, maybe we put the settings below here. All right, so we have this path. What did I do? I don't know what I've moved, honestly. Okay, let me just revert and put this up. Okay, I'm gonna undo. Control M. All right, so I just want to move this below. So we have this, we have this, we have this, download the model. Okay, so I'm just gonna put it, probably just gonna put it here. Pre-trained model path, and put this here. Okay, that should work, and I don't need to create these settings anymore. All right, and let's see what else. All right, so we got this. It seems that we got it working, and that's good. So we have been here for 20 minutes and everything has worked so far, which is great. And you can see here we are running the mutant.png and it's processed, right? So let's take a look actually what we run today. So we have the sample inputs. So we have this mutant PNG that I'm gonna download. So you can see with the system viewer, so this is a mutant.png. And if I go to outputs, sampling, so snapshot, pre-train. So this is the, seems to be the model, right? So where we downloaded it. And we have here the input and the prediction. So we get the mutant prediction, we open, and this is a prediction. So you have side by side, you can see the prediction in the center. So here and farther we have the input. So here already we can see that the re-rendered one has more resolution, right? So at least like the traces are cleaner. Okay, and we get the order compare. So we get this order comparison here, right? So as you can see, the order means probably that the blue was where the sketch started and the red or purple is where it ended. And with moving, okay, and then we have the order here again. So probably this is just the drawing order, yeah. And lastly, we have the sequential data at mutant_0 NPZ. And this is not something we can preview with, we cannot preview it with Visual Studio Code because it's an NumPy array. So what we can do is go to the bottom of our notebook, which has some output. And this actually, so this code here is the code I wrote. You can see here, this is the code I wrote to visualize that NPC file. We looked at what it was. If you look for NumPy MPC file, this is NumPy saves, and this is a format to save several arrays into a single file in uncompressed MPC format. And it provides an array of keywords, right? We can go back and take a look. So we see that the things included there, or the files included, are stroke data, init cursors, image size, round length, init width. And here we have stroke data. The shape of that tensor is 794, or that matrix by 7. We have the init cursors, 8 by 2, which is just this. And we have the image size, the round length, and have 8 values. So we have 8 values here, and these probably are coordinates. And this is also round length and init width and 0.01. Okay, I see here there are values from like 0 to 1.05. I'm not sure what this means, but let's take a look and try to see. So Rob, just a question. Did you paste the link of the model preparation download there? Because I think you don't have rights to. So I'll add you as a moderator and maybe try now to see if you can paste the link on the chat, on the live chat. Okay, so let's see. We were gonna take a look at the virtual sketching repo. And I just want to take a look to see where they mention our vector output is stored in an MPC package. Run the following command to obtain the render output and the drawing order. Results will be under the same directory. Python 3 visualize drawing file path to the result NPZ. GIF making. To see the dynamic drawing procedure, run the following command to obtain the GIF. Result will be under the same directory of the NPZ file. Conversion to SVG. Our vector output in an NPZ package is stored as IK in the main paper. Run the following command to convert it to the SVG format. Result will be under the same directory. The conversion is implemented in two modes by setting SVG type argument single, each stroke a single L segment forms a path in the SVG file. Cluster, each continuous curve with multiple strokes forms a path in the SVG file. Important notes. In SVG format, all the segments on a path share the same stroke width. While in our stroke design, strokes on a common curve have different widths. Inside a stroke, a single segment, the thickness also changes linearly from an endpoint to another. Therefore, neither of the two conversion methods about generate visually the same results as the one in our paper. Please mention this issue in your paper if you do qualitative comparisons with our results in SVG format. All right, so we have a fairly comprehensive document here. We have the visualized drawing, which they probably run every time that you run a prediction, and we have never run the GIF making one. So for this, I'm actually gonna go back to my sketches page, and I'm gonna try to run through this algorithm, some sketch that I have that is fairly simple in terms of being a line drawing. We have run the one with the hand. Let's see which one could be a good candidate. I don't think I have too many good candidates here to run through this. I think we run this one, maybe this one. This one is one of the best candidates that I can see. And we're just going to download this image. Let me see, maybe from here. Let's take a look. Yeah, maybe let's try to make it smaller. Okay, I've downloaded that image. I'm going to convert it into a PNG. So we have our PNG here, and I'm going to upload it to... So I'm going to save the notebook, and everything should be the same when you use this, except for, you know, if you want to upload a custom image, I will say here, upload your custom image to sample to virtual sketching sample inputs clean line drawings after the virtual sketching repo has been cloned. So we can set here, this is going to be, where is this? Ceramic worker. And we're going to put that there in this folder. And this is going to be called ceramic worker. So we're going to try to run that. So test vectorization with our new output name. Let's see. And all right, so that seems like it's running. And after we do this, we'll run this to make sure that the NPZ file has been generated correctly. And after so we're saving the results, it seems like this image was fairly easy for the model to tackle. And here we're gonna add a new block, and we're gonna say generate GIF animation. Hey Major, thanks for popping by, and I'm glad that you're connecting. Do you want to tell us what are you working on? What new content have you been creating as of late, and what can we expect from you in the in the short term, I have been following a bit of what you've done. Have not had time to watch everything, but I've seen some stuff. So I would be really happy to share with with everyone who watches this what you're working on as of late. I will also comment that I'm almost done with. Tomorrow, I think I'll release a new podcast episode with Aram Menges, and we talk there about visual programming, Bitcoin and NFTs, social fintech, and some lessons that he's sharing about creating software products and building things with startups. Anytime someone asks for a creative AI YouTube channel, I refer them to your channel. Thanks so much, Major. You're creating a ton of nice content, and I really, really appreciate. I also don't know how you have the time to put so much stuff out there. All right, and I'm gonna, you can keep writing on the chat. I'll be looking. I'm going to. Oh, okay. So one sec. We got some. I'm different. So Majur says here, I'm doing some experiments on smart contracts and mostly on blockchain in AC at ArchiDAO. I haven't been doing too much there. ArchiDAO.io, did you buy that one? Dedicated novel ways. Yes, so they're hangouts, and this is ArchiDAO. Web3 first architecture design technologies, developing solutions and experiences. CryptoVoxels, participants, Acom. Nice. A lot of stuff going on. I need to catch up. Right, let's keep going with the exercise that we're doing here. I was here, so I uploaded a new sketch, which is this one, Ceramic Worker. We uploaded it to the right folder. We executed the algorithm, the prediction completed, so the vectorization. We're previewing here the data, and now we're going to generate a GIF animation. Generate GIF animation from NPC results. All right, and for this, as we can see on the README, we just need to do Python 3 tools GIF making .py, and we specify our file, which is also here, right? So we'll basically, let's do one thing. So we're gonna do here NPC file, so NPC path, and we do that, and we put here NPC path. All right, so we run this. Okay, so 1 second, we'll put this thing in here, and we'll run this again. And then here, we're gonna say that file equals NPC path. Let's see what happens. And this command is going to arguably generate a GIF animation of our yes, and it seems like it's working. So I don't know what the TensorFlow one is for, but it seems like this is being made. And saving GIF, and that's done. Okay, so Majur also says at ArchiDAO we're doing some metaverse experiments and workshops in case any of your viewers is interested to learn. Where can we see that? Where can we see information about that? Let me pop the website again. So projects, roadmap, vision, team, join. Where would the people follow that? Maybe on Twitter and Instagram? Archi_DAO. 2 of March, that was yesterday. Yeah, you can feel free to send me links or something. I don't know if you can post links to the live chat. Okay, so let's see if we got the GIF. It said before that it will be on the same folder that we had the sequence data. Ceramic worker dynamic.gif. All right, this is exciting. Let's see if this actually works. That is pretty cool. All right, so yes, so this is let me actually, this is exciting. So this is actually a sketch that we input as a raster, and it's now being rendered. I don't know how big this is. It's now being rendered as right. So I wish that was faster. Let me take a look. So let's see what else we could do here. So we have GIF making SVG conversion. So let's try that conversion to SVG. PC path, and I'm gonna run that conversion to SVG. That was pretty fast. Let's see if this worked. SVG, single dot SVG, because we didn't specify a mode. So we have here single SVG. Nice. All right, so now we're talking. So this is a vector version of my hand sketch, and I'm, let me actually jump to the other side of the window. Yeah, so this is a vector representation of a sketch that I've done by hand, and I think it's pretty impressive because it's stroke based, and it has some concept of thickness, and it does look really, really, really similar to the one, so to the original sketch, right? So that's really cool. And if we take a look at this sketch, right? So this is a sketch, and you can see that the traces on the sketch are imperfect, right? So they have you can see different artifacts there. And if you look at the vector form, this would allow me to probably reconstruct the drawing and scale it up and print it high resolutions, or at least make a hybrid, and also to probably animate it and render my sketches automatically in many different ways, which is, I think this is super exciting. So I'm really glad that this is working. Kudos to the guys of the algorithm, right, who made this. So Mark, Mo, Haora, and Mo, thanks a lot from the live stream. Thanks for doing this and making it open source. This is crazily good. Okay, so what else do we have here? So we also have visualization, which I think that's the same that we already have. And let's specify this SVG type argument to see how this works. So we can do single, and then we can do also cluster. So let's try both. Then we refresh and we get cluster here. And then now we can compare both of them. So cluster, I think, doesn't have thicknesses, and single does have different stroke segments with different thicknesses, but not different thickness along the same stroke, which is what the authors of the paper actually mentioned, that they have variable thickness, I think. So I think that's what they mean, right? So they do have variable thickness. So you can see here, this is an interpolation of thickness, and it's probably not vector form, I'm not sure. So let's take a look at the drawing algorithm. And yeah, so this concludes a bit looking at the algorithm and seeing what we can do with it. Now we need to play a bit more with it. I'm gonna put here the files of Flight 63 so we can keep track of them. And now, so let's ask, so let's see what Major is saying here. Can we make the sketch autoregressive human-machine co-creation with tweaks? Yeah, what do you mean exactly? I mean, yes, we could do that. We could probably do it. My intention is to try to vectorize things that the human is drawing as you're working on it, or maybe get things that are from the physical world, like a scan of a sketch like here or some other image, and try to bring into vector form so we can animate it and do other things with it. I also do have this tablet here. So we have the, let me go, it's no longer active. Let's see, this goes to sleep after some time. Let's actually try this one now that we have the pipeline going. Let's actually get this image and let's make it also 124 by 1024. We're gonna put this here, and we're gonna put here HyperCard. This is the name of the chair. HyperCard. I don't know how to pronounce it properly. HyperCard. All right. And we once again go to our clean line drawings. So we just need to drag and drop there. Clean line drawings. And we put it there, and we just copy. Oh, this is a JPEG. I'm not sure if it needs to be a PNG, but let's actually just try with the JPEG. Let's see if we break it now. All right, so we put this input name is here. All right, so let's run the prediction and all the other cells below it. So we can deploy this in real time. Yes and no. I mean, we could. It's dependent on some Python models, and it runs in TensorFlow Core, an old version. This model is not ready for TensorFlow JS, if that's what you mean, if we can interact with it live. That would be a really cool experiment if we could port ourselves this model to run on basically when we have a trained model, we can run it on TensorFlow. Yes, that would be, but that's a project on its own, right? Like otherwise we will have to deploy an endpoint. It takes some time to renderize. To render. Okay, so My bad here. It takes time to render. But yeah, it takes some time to predict. And I don't know if we can do that. But I mean, my intention is there. So let's see. Okay, so we'll do this. The prediction seems like it worked. And we'll get here sec data, hatef hall, and NPC is here. The dynamic GIF is being generated and has been generated now. Yeah, so we keep, we go and get everything here that we were expecting. So we now get the GIF. Well, the GIF is saving. So if I download it now, probably it's not complete. And now we also have the two SVGs, the cluster and the single SVG. So let's see how this worked. This is my vector chair, right? Like what I said before, like it doesn't work for everything. I'm not sure if it has a maximum amount of strokes that it can handle. We need to figure that out. But if we get this animation, this is the animation of our chair. And yeah, that's awesome that it's trying to write my handwriting in vector form, and that's pretty cool. This is really promising. This is gonna be really cool. All right. Um, Hello, Jose Luis. ParametricCamp is here. We got it. So we got it working, Jose Luis. This is, I didn't write this script, but I managed to make it work. So we do have a better example that I was showing before in case you're curious. So this other one works completely. I'm not sure why the other one missed some sketches. So Jose Luis, welcome to the live stream. What have you been up to these days? Let's share it with our audience. Let us know what's new. Can we see on the ParametricCamp channel, and what can we expect from the near future? Jose Luis and I actually talked about doing like a collaboration, which I think I'm ready to make and to happen. I'm gonna play with the stroke data and the vector data from here, but what we want to do is like a two-part video where I explain the machine learning process to get this going, which we sort of have done over the last two live streams, and then he shows how to render the sketches or animate them or something in processing or Grasshopper or like P5 or something like this. OG Architectist YouTuber here. work in the real world. Boring. We're wrapping up advanced development in Grasshopper. List in the channel. All right. So we do have access to that. So we do have congrats to Jose Luis for his ramping up, more than 6K subscribers already. And so this I shared this morning on our Discord server, which is his playlist, ParametricCamp playlist. To it's an introduction to computer programming for designers using C#. There's a bunch of stuff here, and this is crazy. This is like a crazy amount of work. Congratulations, 70 videos. And let me see if I can go back to our, where is this? All right, and then this one in progress. This is, let me swap places. This is an advanced development in Grasshopper playlist, which already has 36 videos and I don't know how many hours of content, but really, really nice. From the basics, why write code in Grasshopper? Fundamentals of scripting. So this is awesome. So I'll recommend you to check it out if you want to learn computational design, parametric design, and how to code and generate geometry with code. All right, what else? So Jose Luis, just a thing I didn't get to share with you yet. I'm live streaming from my MacBook Pro M1. So this is the Apple Silicon. I'm running a beta. Is a beta? I don't know. I'm running a development build of OBS for M1 chips, and this works pretty well. This laptop is pretty. I mean, it was pretty cheap compared to some of the new M1 Pros and M1 Max. And I've used one of those, and those are super fast. And I can't imagine when the final OBS, like the official build, is ready for M1 Apple Silicon chips, and also using some of those new laptops. All right, what else do we have today on the chat? Apple. Jose Luis has some internal battle with Apple and Python. And and Majur says that he actually won 2 hackathon projects using WebSockets, which he learned from Professor Jose Luis. That's awesome. I mean, we do love WebSockets. I think that's one of the real-time interaction is one of the most rewarding things that you can do when you have software, because you see different parts interacting with each other. 70 videos, yes. And Mayur says that he always sees Professor Jose sharing his adventure stories on Instagram. Apple and Python, not a good combo. Why not? I mean, you have Docker everywhere, and we have Python here. We can run anything with Conda. Python works pretty well. Import TensorFlow as TF, blah blah blah. Breaking everything. All right, so thanks guys for connecting live. I have one pending item. Are you making, Jose Luis, are you planning on making a tutorial on Rust? I think Rust is used for, I mean, as at least as I've seen on Solana, smart contracts like crypto and stuff. I think Rust is really used on Solana smart contracts, but I've never used Rust actually. Jose Luis, have you used Rust? Oh, okay. I didn't catch the reference. Sometimes that's a good reference actually. We need a debate podcast of Nono and Jose Luis on Apple and Python. Challenge accepted. Apple and Python. Man. Yeah, when are we going to do a podcast? Jose Luis? We have one long overdue. So Algo. We started this Algo series on the podcast and we never continue. I mean, we did a few more episodes. We have the free diving one, and we also have a Q&A that we did. But we need to record more often. I think so. The language, you can organize it. Yeah. Major, you should organize the call. That would be good. I'll be in for that if you organize that call. And yeah, okay. What else? Do you guys have any other topics you want to talk about. I was on my bucket list now. You have so many things going on, Major. I also had this thing here that every time that I switch it on, it disconnects. Um, okay, so the one thing that I wanted to try to do to see today as well was to get the tools and see how they visualize drawing, how they make the GIF, right? So for example, from the GIF making script, we can probably reverse engineer how the network is, well, the program is just reading the NPZ file, and, and render it. The language is getting popular on my bucket list now. Let's do it. I'm always down to host you guys. Yes, we should. We should. I think we need to do more, and I think it would be good to do it live. Like if we do it live, that would be really cool. Okay, so you tell me, do we continue with the with this, or do we move to something else? Got it. Let's see where this is. Let me see if I can get back at the. So let's try to recap here. So as a quick recap, let me take a look and see what we've done. All right, life in the metaverse. Yeah, haven't been doing. I've been interviewing, so in on the interviews, and I'll show, who cares. I'll show a. So this is a spoiler of the new podcast episode that I'm gonna release. So this is the latest I've recorded with Adam Menges. So you're the first to see this, and this is almost ready to be released. We have, here are the topics. We talk about AI, visual programming languages. We talk about Grasshopper, actually. We spend some time talking about Grasshopper, Jose Luis, if you care. Um, Lobe, some stuff of like programming and how that can help reduce polarization in the workplace, and basically help people author things and create programs without having to be super technical. And we also talk about COVID stuff, Bitcoin, NFTs, crypto, social fintech, and some other things. So this will be out hopefully by tomorrow morning. This will be out. It's a 1 hour long episode, long form as I like them. And yeah, so you'll probably hear more about it tomorrow. Okay. And HyperCard. Yes, I actually didn't know what HyperCard was, but it's super relevant for the for the history of software development and applications. Have you used HyperCard, Rob? All right, so let's actually take a quick look at this. So we've been going for an hour now, and try to see. So maybe we can continue the next live stream on this and try to actually draw some of these things by hand, like actually drawing the the strokes ourselves. Okay. Mm-mm. And also, now that you're live, that you're online, thanks Jose Luis. Thanks Major. Thanks Rob for being online today. It makes my day just to have a few people here talking on the live stream. And I haven't done like a community meeting or anything yet, which is really long overdue. And we should gather at some point, so it's not just me talking and you guys talking on the chat, but that we can all talk on Zoom and have a conversation. Make GIF. image size cursor. All right, so when we run this script, we just call the scripts, right? So this calls GIF making, and the argument is the file path, right? So that is the main argument in that function. So if we go to GIF making NPC path, min window size, raster size, blah blah blah. So yeah, I just want to try to understand the way that this is being rendered and that everything's happening. So maybe GIF making is not the best. All right, so here on the chat, Jose Luis has let me just pull the chat again. I need a better way to do this. Like this feels a bit sketchy just to put the chat here, but you know, it sort of works. Jose Luis votes for a community gathering, I guess. Rob says that he learned Aldus Freehand 1.0 via its HyperCard stack. Well, I need to learn more because I don't know what that exactly means. It was fun, really admire the consistency and quality of the content. Yes, I wish I could, produce more, not more, but produce better content, because it takes a lot to edit the material and actually get videos out there that are edited and are easy to watch later. Time for a retreat in Spain. I'm always welcoming people in the south, so you're invited anytime. You can come by and we can go free diving or record podcasts or do whatever. All right, let's quickly, before I go, it's getting late here. I'm going to take a look at the visualize drawing .py. Let's see what this one does. So we go to the bottom of the script again, visualize drawing with a file path. So let's see the definition of this. And what I had here before, okay, so I have connection now, because if I leave this, all right, so this message is held for review. I don't know why. This is funny. So why on earth would this be censored or something? Show scuba freediving. Freehand was one of first vector drawing tools for Mac. Nice. That's awesome. Okay, so here I'm gonna look for dev visualize drawing. So we have the utility function here. So this looks for the file, make their differentiable pasting graph. I need to learn more what this is. What is this differentiable pasting? Let's take a look at this. Let's just put this, and I'm going to save this on my slides so we can have a reference from it next week. All right, so this is in this file. All right, what is this differentiable pasting graph? Div pasting. Model common test div pasting v3. We'll have to take a look at that. So we were looking at display strokes final. Param end strokes 9. All right. Just for a quick recap of what we've done today. So we did have a Colab notebook with our Python cells that we actually executed, and everything worked well. So this was actually getting a an image as an input. And we were getting a set of like an NPZ file. So let's, all right. I know Jose Luis like those sound effects. And yeah, this one actually, apart from other things, it does contain vector data, and from there we actually have scripts that are provided by the algorithm to make a GIF animation, to export as SVG in single in cluster format, and we also have the visualization, which has like raster order visualizations. And yeah, so this is what we've done, and now we're trying to see what these methods here are actually doing for us, right? Like what we want to do is actually create a new script, so that actually a script that parses, or like not parses, but script to read and render strokes. And this is probably going to be for live 64. Oh, hello, Sajeh. It's we started a bit later today. How's it going? Thanks for popping by. I'm surprised of like how consistent you've been in showing up. Like if I don't see you online, I say like, did something happen to Sajeh? So thanks so much for being there. Um, okay, so what do we have here that we can take a look at quickly if we can understand? Display strokes final. What is this doing? Run. So it's interesting because this actually saves the NPZ file, and then it reads it uses TensorFlow to read the NPZ file. So it passes the session. All right. So we can definitely get quickly the x and y coordinates of the different strokes from here. But I would like to understand a bit more what they're doing with this interactive session. So let me actually cancel the editing of this file. Let me just look for session. Image pasting v3. Where's this? Utils. Image pasting. Patch image, cursor, image size, session. Pasting, func, pasted image, feed dict, patch canvas, cursor, image size, window size. We need some more time, I guess, to pasting function. Pasting function. Where is our pasting function? Pasting function. Display strokes. Paste v3 function. Div pasting v3. Differentiable pasting graph. From model common test. Model common test. Div pasting. This is a class. Patch canvas. Image paste. This is complicated. Yeah, so if we try to take a look at this today, we don't have time. As I said before, it's easy to just use this and get the x and y coordinates. Maybe we want to dig down on this and try to understand a bit more what it's doing. It seems a bit complicated though, but we might. So let me just take some notes here. So here we do have 30. So from here we have class div pasting, and this can be and then we're going to get the utils, and we do have that image based v3 testing. All right, well, that was it for today. I'll just stay for a bit more in case you guys have any questions or any comments. As always, thanks for being there. I would remind you, if you are watching this offline or if you're live with us, remember that you can support the work that I'm doing here with these videos and these tutorials by liking the video, and also that you can subscribe if you want to get notified when I go live next or when I upload new videos. I would also mention that some links that I put on the description help support the podcast because those are referral links or affiliate links. And, I'm trying to build also some sort of support for the time and resources that I spend doing these live streams. You can join the community at None of the Masas Discord, as always, and we can see you there. Thanks a lot for watching. I'll see you next week. And special thanks to everyone who connected online, or also if you're watching offline, leave a comment, let us know where you're connecting from, and ask if you want to know anything. Ask, we can cover it on the podcast, maybe even go to the Discord community and ask things there. So yeah, um awesome. So Rob says I'm successfully getting SVGs and GIFs. That's awesome. Yeah, no, thank you for following along and for telling me about this paper. I would like to learn more. This looks like a really interesting um, paper to learn more about because it not only talks about what it does, but it has this concept of a drawing window and like a differential pasting equation that, um, yeah, I would love to learn more about it. But it's not easy to understand these concepts, I think. My opinion. I mean, it's not easy for me, at least. All right, so I'm gonna close things here. So we are done but not done, and shutting the lights off. Okay. Well, again, thanks so much for being there, and I'll see you soon. New podcast coming out tomorrow.